Hello everyone, in this video we will be talking about friction, or the friction force. The friction force happens when two surfaces are in contact with each other. So, if you imagine the ground, on the macro scale we can see it's something more like this, where it seems very smooth. But microscopically, there's very, very, very tiny obstructions and irregularities. And similarly, on anything we use on other surfaces, they have such irregularities, and when they're in contact with each other, they clash together. This causes the friction force. The friction force allows us to do many things like walk and not, slip away. Now, there are two different kinds of friction that act on an object. There is static friction and kinetic friction. Static friction happens when an object is already at rest and hasn't begun its motion yet. So let's say there is a box and you're trying to push the box. Now, the box wasn't already moving and it was at rest. So until the box starts to move, it has static friction acting on it. Now, let's say a box is already moving and you keep pushing it. The friction that occurs when the box is already moving, or an object already in motion, and the friction between the surfaces of the object and the surface on which it's moving on, that involves kinetic friction. Typically, static friction force is higher than kinetic friction force. Now, depending on the problem you're looking at, whether the object is already in motion or is still at rest, you must be sure to use the correct kind of friction, because the same surface can have two different amounts of friction force acting on any object that is moving on it. So we separate these different kinds of surfaces using coefficients, which are coefficients of friction for static friction, which we represent as mu s, and kinetic friction, which we represent as mu k. And we use these two coefficients to separate the forces that are acting on the surface. The general formula for the force of friction is the coefficient of friction times the normal force exerted by the body. Let's look at an example. Here's our example problem. Let's say we have a 10-kilogram box standing stationary on the ground with a rope attached to it. Let's say someone wants to move the box from its initial position and uses the rope to pull on the box. When this person is using the rope, it is elevated 30 degrees above a horizontal and pulling with a force of 100 newtons. We want to know if this 100 Newton force is adequate to move the box or have it overcome friction. Now, a key word in this problem was that the box was stationary initially, so we must use static friction. Typically, problems will give you both the static friction coefficient and the kinetic friction coefficient, and you will have to determine which one to use. So pay close attention to the wording of the problem. Let's get started. So, whenever we're dealing with a force problem, always draw a dot diagram. So, let's say this dot represents our box. We know the force of gravity is pulling the box down. We know the surface on which the box is staying is exerting a force upwards, which is our normal force. We then have a force due to the rope, acting 30 degrees above horizontal. So we have an x component for this force and a y component for this force of 100 newtons. And finally, we have the force of friction, which will attempt to keep the box stationary. Now that we know all the forces that are acting on this box, let's get started. So, we know the force of friction is the coefficient of friction times the normal force. So we must first find the normal force. In the y-axis, our sum of forces equals our normal force plus the y component of the exerted force minus our force due to gravity, which is going down. Now, since the box is staying on the ground, not going through the ground or flying in the air, we know the sum of forces will equal 0. So we know the force of gravity, which is 9.8 times our 10 kilograms, equals the normal force plus the y component, which will be 100, and if we do trigonometry, we have sine, so it'll be 100 times sine of 30 degrees. So our normal force will be 48 newtons. Now, since we have the normal force, we can find the force of friction, which will be 0.5 times 48 newtons, which gives us 24 newtons as the maximum friction force exerted by the static friction. Now, how can we tell whether or not the box will move? So we know the x direction, our force from the rope must be higher than the force exerted by the friction force. So what is the x direction force exerted by our 100 Newton force that we're pulling the rope with? So in the x-axis, the x component of the force will be 100 newtons times, since we're dealing with the adjacent side, we'll have cosine of 30, which gives us 86.6 newtons. Now, as the force exerted is higher than the force of static friction, we know the box will move. Thank you for watching, and see you for the next video. I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what physics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you're a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website at www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online, or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.